The question says among the following ions, which one has highest paramagnetism? It means that which complex is highly paramagnetic by nature. Okay. And we have learned paramagnetic nature depends on the number of unpaired electrons. Higher the number of unpaired electrons, higher is the paramagnetic nature. Okay. And whenever the question is talking about geometry, hybridization, or magnetic properties, always apply valence bond theory. It is easy to use. The steps we follow to apply valence bond theory: first you have to write oxidation number of central metal atom, then write electronic configuration of central metal ion, then write orbital notation considering the effect of ligand. Okay, considering the effect of ligand. If strong field ligand, pairing of electron, weak field ligand, no pairing of electron. And from here you can answer this question, because at this step you can calculate the number of unpaired electrons. Okay, pay attention very carefully. One by one we can calculate the number of unpaired electron in each complex. Okay, first we have to find out the oxidation number of central metal atom. So we have Cr and it is H2 is there. Keep in mind H2 is a weak field ligand, and weak field ligands means no pairing of electron. Okay, calculate oxidation number. Overall charge is what? +3, and Cr and 6 water molecule. Water molecule is a neutral ligand, will have 0 charge. Cr is present in +3 oxidation numbers. Okay. Then we write electronic configuration for the central metal ion. From here we are getting central metal ion having +3 charge. Okay. Chromium, atomic number 25, electronic configuration 3d5, it is 4s1 is there. Okay. Since it has +3 charge, it is losing 3 electrons. 1 electron from here, 2 electron from here. As a result we get 3 is there. Right. Orbital notation. So we have Cr3 plus is there. Orbital notation, d orbital. How many boxes? 5 boxes. This is your 3d, 3 is there. Then 4s orbital. Then next we have 4p orbital is there. Okay. Before filling the electrons, consider the effect of ligand. What kind of ligand we have? This is a what? Neutral ligand, but it is a weak field ligand. Water molecule is considered as a weak field ligand. Means no pairing of electron. We follow Hund's rule. First spin, second spin, and third spin is this. How many unpaired electrons it has? 3 unpaired electrons. I can write chromium. Here we have 3 unpaired electrons, central metal atom. Okay. Then we can follow the same step in case of next complex. Okay. It is CuH2O whole 6 and +2 is there. We have CuH2O whole 6 and +2 is there. +2. Okay. Overall charge is what? +2. Copper +6. Water molecule, neutral molecule 0. Copper is present in +2 oxidation numbers. Okay. Then write electronic configuration for the central metal ion. Central metal ion is what? Copper present in +2 oxidation number. Atomic number of copper is what? 29. Electronic configuration 3d10. It is 4s1 is there. Cu2 plus means losing how many electrons? 2 electrons. 1 electron from here, 1 electron from here. It is 3d9. Okay. Cu2 plus having 3d9 electronic configuration. Then we go for the orbital notation. Okay, keep in mind in each complex we have neutral complex water, that is a weak field ligands. Then we have d orbital 3d9, it is 4s. Then we have 4p is there, 4p. Okay, 3d9 1 2 3 4 5 6 7 8 and it is 9 is there. Okay. First singly filled and then double filled, because weak field ligand is there. Okay, but whenever if 3d9 is there, whether strong field ligand or weak field ligand, this is the arrangement we are going to get. Okay, we get only 1 unpaired electrons. In this case we are getting only 1 unpaired electrons. Okay, we have 1 unpaired electrons. Let me write it on record, it will be there. It has only 1 unpaired electrons. Then we go for the C option. Okay, FeH2O whole 6 2 plus is there. Okay, we have FeH2O whole 6 and overall charge is what? +2. Then is equal to +2 we write. This is Fe. Water molecule 6 is water molecule 0. Then Fe is present in +2 oxidation number. From here we got central metal ion Fe2 plus. Okay, right. Electronic configuration, Fe atomic number 26, outermost electronic configuration 3d6, it is 4s2 is there. Fe2 plus, it is losing 2 electron, then we get it is 3d6 is there. Go for the orbital notation. Okay, go for the orbital notation. We have d orbital, how many box is 5, 3d 6 is there. Okay, then we have 4s, and in the last we have 4p is there. Okay, start filling electrons. In this case also we have weak field ligands, no pairing of electron, 1 2 3 4 5, and it is going to be 6 electrons are filled. Now you can see how many unpaired electrons we have. This is 1 2 3 and it is 4 unpaired electrons. On record we can write we have 4 unpaired electron. Very good. We have 4 unpaired electrons. We have 4 unpaired electrons is there. Okay, so till now the answer which we are getting, that is the C option, because it has maximum number of unpaired electrons, means it will be highly paramagnetic by nature. But anyway, we can calculate for the zinc, option D also. Okay, zinc H2O whole 6 plus 2 is there. Okay, last one also we can see whether if it is having also more number of unpaired electrons. So we have zinc and it is H2O whole 6 and power plus 2 is there. Okay, in this case overall charge plus 2, zinc water molecule 6 is multiplied by 0, zinc is present in plus 2 oxidation number. From this complex we got a central metal ion zinc having plus 2 charge. Atomic number of zinc is what? 30. Electronic configuration 3d 10 and it is 4h2 is there. Then we have to write electronic configuration for zinc 2 plus, it will be 3d 10 is there. Okay, very interesting, 3d 10. Then go for the orbital notation. D orbital is completely filled. There is not a single unpaired electrons. Okay, whether we write or not, it is very clear. Okay, so we have 3d 10 is there, 1 2 3 4 5 6 7 8 9 10. There is no any space left. Singly filled, double filled, you will get the same arrangement only. This is what 4s, no electron, and 4p is there, no electron are there. So in this case we do not have even a single unpaired electrons, means it is what? Diamagnetic by nature. We can say last option is what? We have diamagnetic by nature because it does not have any unpaired electron. Okay, which option is correct? We are getting option C. It has maximum number of unpaired electrons. First one is 3, second one is 1, and C is what? 4 unpaired electrons. Hence we can say it is highly paramagnetic by nature. If you like this video, please share and subscribe to the channel.